Hi, welcome back. Today we're going to talk about constant acceleration. Previously we talked about constant velocity, and so if we refresh ourselves, if you have a position time graph that constantly changes position with time, a directly proportional relationship, the slope of this line is the velocity, or you could say it's the derivative. So when I plot this line, this rate is continuous. It's the same all the time. And so it would be a positive velocity. Now what that means is that if I started at position 0 and continuously moved away to some large position away from my starting point at a constant rate, that velocity is going to be positive. So this velocity time graph can also be understood as away and towards. Well, today we're talking about constant acceleration. So what happens when that position time graph looks like this? Has a curve to it. Well, what we're seeing here is that if I take the instantaneous velocity at this point, I see that it is positive and relatively small. If I go up further on the graph, I see that it's still positive, but it's much steeper. And so that translates this constant acceleration, where I'm moving away from my starting point at a faster and faster and faster and faster rate, that translates on my velocity time graph into a slope. And so if I had a small positive velocity and I had a steep or a large velocity, but still positive, remember this is all positive, this is all going away, my graph would look like this. Now in a velocity time graph, the slope is going to be A, because we said that the acceleration is change in velocity over change in time. Just like when we said velocity was equal to the change in position over the change in time, where V is your slope, here A is your slope. So this constant acceleration of a positively sloped acceleration would be translated onto a acceleration graph as a positive number. We're going to go through some scenarios here. So in a position time graph, if the curve was exponential like this, where I was moving away from my position faster and faster and faster, I would still be moving away at a constant velocity, and that acceleration would translate into being positive. If I started far away and I slowly increased my speed towards the origin, I would have a small negative and a large negative velocity. And so a small negative and a large negative velocity would look like this. And my acceleration would be a negative slope. If I started at my origin and I started out really fast, but then I slowed down while I was moving away, I would have a curve like this. And this is a large positive velocity to a small positive velocity. So a large positive velocity to a small positive velocity would look like this. Now that is a negative slope also. If I had started far away from my origin and I quickly moved towards it, but then as I got to it I slowed down and stopped and never actually approached it, I would have a steep towards, so a large negative velocity, and then I would have a small negative velocity, and so a large to small negative velocity would look like that. And that slope is going to be positive like this. Now there's a lot of different scenarios here which would go through what the object was doing, where was the object moving, how was the object, or how fast was the object, and then was it slowing down or speeding up. And so you're going to need to know the relationships between these types of graphs, and specifically the circumstances of the sign of the velocity and the acceleration. So if I had a positive velocity and a positive acceleration, the object would move away at a faster and faster rate from the origin and continue on forever. If I had a negative velocity and a negative acceleration, kind of the same thing happens, right? I'm going to move towards the object, or the origin. The object will move towards the origin, and it will continue on forever and ever, and it will continue to get faster and faster and faster. So even though the velocity here is positive, you notice that the numbers get bigger to infinity. And even though this velocity is negative, the numbers will get bigger, the magnitude of the numbers will get bigger to infinity. And so whenever you have the same signs for velocity and acceleration, you will see a speeding up, where my velocity is positive and my acceleration is negative. Now this is a little bit tricky because the velocity here has a negative slope, and we would say it's going down, and so we'd say that the velocity is negative, but you got to be careful. All of these velocities reside in the positive region. So even though this is a negative slope, remember the slope here is acceleration, not velocity, and so all of these velocities are positive, but the acceleration would be negative. And so what happens here is that you would be moving away, the object would be moving away from the origin, but it's slowing down to the point where it's going to stop. In this instance, we're going to switch it. The velocities are all negative, and the acceleration is positive. And so same type of thing, you have this stopping. So I came towards the origin really, really fast, but then I started to slow down. So I was moving, the object was moving towards me, and then it was slowing down, and then it approached zero, and it never actually reached its destination because it stopped. And so when you have a difference in signs of your velocity and acceleration, you see a slowing down and oftentimes a stop. So this is a kind of a lot of individual thinking, and the best way to think about these is pick points on the graph to try and identify, okay, this is a positive acceleration. That means that it's going to be a positive velocity slope graph like this. And what does a positively sloped graph mean? Well, it means that I'm moving away from my object at a constant change in velocity. And so I'm going to get faster and faster and faster as I move away. And then up here, you would go into the positive because you're going away from your origin in that manner. And so try to pick a point on these graphs and kind of talk yourself through that. What would the slope of the next graph be?